In this video, I'll be discussing the topic of a new discovery, the largest explosion in observational history. In 2020, a research team including members from the University of Southampton made a new discovery of the largest energy-releasing explosion in recorded observation history and announced their research results. This enormous explosive phenomenon has been named AT 2021 LWX. AT 2021 LWX was discovered taking place approximately 8 billion light-years away from Earth. In a location where there had been nothing before, an incredibly bright flash suddenly appeared, at one point shining with a brightness about 2 trillion times that of the Sun. Although it has gradually been dimming since, even 3 years after its occurrence, it is still extremely bright. Not only did it shine extremely brightly, but its duration was also incredibly long for a sudden explosive event, leading to a total energy release that is believed to be the largest in observational history for such phenomena. Recently, the largest observed gamma-ray burst in history, GRB 221009A, was discovered. This burst's instantaneous brightness was 70 times brighter than any previous gamma-ray burst, even brighter than AT 2021 LWX. However, while the duration of GRB 221009A was considerably longer than other gamma-ray bursts, it was still much shorter than AT 2021 LWX. Therefore, the total energy released by AT 2021 LWX is far greater. In that sense, AT 2021 LWX is considered the largest explosion in observational history. While the true nature and the mechanism behind AT 2021 LWX remain unknown, 3 extremely bright celestial bodies or phenomena have been suggested as candidates. The first is the quasar hypothesis. Quasars, incredibly bright celestial bodies often seen in distant parts of the universe billions of light-years away from Earth, are known to be the brightest objects in the universe, excluding transient phenomena like gamma-ray bursts and supernova explosions. Quasars are believed to shine due to supermassive black holes at the centers of distant galaxies continuously accreting large amounts of matter. Matter that approaches the black hole orbits at incredibly high speeds due to the black hole's strong gravitational pull, causing it to heat up to extreme temperatures and shine brilliantly. The only known celestial bodies or phenomena that can emit energy equivalent to AT 2021 LWX are quasars. However, quasars are not sudden explosive events, but rather celestial bodies that shine continuously over a relatively long period. Therefore, the fact that no bright celestial body can be found at the source of the explosion, even when analyzing several years of observational data, contradicts the possibility that AT 2021 LWX is a quasar. The second hypothesis is the supernova explosion hypothesis. Supernova explosions are massive explosive events that occur at the end of a star's life, specifically those of high mass. However, there are problems that the supernova explosion hypothesis cannot explain. One such problem is whether a star of high enough mass to cause a supernova explosion on the scale of AT 2021 LWX can even exist in the first place. AT 2021 LWX is more than 10 times brighter than any known supernova, and furthermore, its duration is also extraordinary. While a typical supernova remains extremely bright for only several months, AT 2021 LWX has been shining brightly for over 3 years. Because it is difficult to conceive of the existence of a star with a mass large enough to cause a supernova explosion of this magnitude, the hypothesis that AT 2021 LWX is a supernova explosion is not highly favored. The last hypothesis is the tidal disruption event theory, currently the most promising explanation for AT 2021 LWX. Tidal disruption events occur when a high-mass black hole completely destroys a nearby star or similar celestial body. Like quasars, which are thought to shine continuously due to the supermassive black hole heating surrounding gases to extreme temperatures, tidal disruption events involve a more massive body being shattered and temporarily shining with an explosive brightness. AT 2021 LWX is 3 times brighter than any known tidal disruption event, and its duration is exceptionally long, compared to typical tidal disruption events that last only a few months. This inability to explain its scale with known phenomena is similar to the issue with the supernova explosion. However, in the case of tidal disruption events, it would not be surprising if a more substantial event occurred, considering a more massive celestial body was destroyed. Although the chances are slim, it is plausible. The most likely scenario currently proposed for the occurrence of AT 2021 LWX is that a supermassive black hole, with a mass more than 100 million times that of the Sun, is slowly consuming a giant gas cloud with a mass more than 5,000 times that of the Sun. However, at this point, sufficient evidence to confirm this scenario is not available. Hence, future research will involve observing light at more wavelengths to validate this scenario further. Thank you for watching this video. Please subscribe to the channel and give it a thumbs up. Let's meet again in the next video. Bye.